Good morning, friends. We are learning our subject, that is data mining, 3160714. And in that, we are learning our chapter or module 2, that is data pre-processing. Let's see, or you can say, let us recall what we have studied in previous lecture. So, what we have studied in the previous lecture? Data cleaning is required because of the data in real world. If incomplete, noisy, and or inconsistent, quality data can provide quality mining results, right? So now we want to know about multidimensional measure of data quality. So what is that? Let's see. Measures for data quality. A multidimensional view. So what do we consider as the measure of data quality? We say that accuracy. Correct or wrong, accurate or not, completeness, not recorded, unavailable. Should it be there? No, that is incomplete, right? So, what should we take care of is if it is not recorded or unavailable, we should take care of that to make it complete, right? Consistency, some modified, but some not. Something like dangling reference. So we should take care of the consistency, but let us say that consistency is not available in the data set. We should do the action by which we are having the consistent data. Timeliness, timely update. Is it timely getting updated? Do we want to have such data? Actually, not in the way that we do not want to have the continuous transaction processing on the data. See, this subject we are learning wherein typically we are considering the historical data. Typically, I am saying, right? So, in general, we say that we are using the data warehouse, and typically we consider it is having the historical data, not the current data where continuously the transactions are there. No, it is not like that. Okay, so timely update, is it having? Is it available? Yeah, that is maybe say 10 years past, 10 years data was there. Then as the time was growing, was the data was updated for some changes or not? If we require to have those fields important for our processing, we should update them. But that update is also rare. It is not frequent, right? Okay. Believability. How trustable the data are correct. Are they correct data? Are they trustable data or anything like fake you are having and you are processing on that? Is it like that? You have to check it out with particular authentication and getting the data. Fine. Interpretability. How easily the data can be understood. See, we are talking of these terms as measure for data quality, but here what we have seen, that is only written in the way simple words, or we can say layman's terms. Is it written like accuracy means something like these many numbers divided by these many numbers? No, it is not so, isn't it? So these are not the actual formula or actual definitions. We can say they are the layman's terms, or just to understand what these terms are, the words, the sentence are written. Okay. So, what is broad categories of the data we are considering? Intrinsic, contextual, representational, and accessibility. These things we should consider about the data quality, right? Now, major tasks in data pre-processing. You can say we have already started with the data cleaning. Yes, because when we are having the data, we can think of whether it is noisy or incomplete or inconsistent. So we have started with the topic that was data cleaning. But what are the major tasks in data pre-processing? So data cleaning is one of the tasks in the pre-processing, and that is considered as the first thing which we should do on the data, right? Okay, so let us consider fill in missing values. We have talked of the need of data cleaning. We have talked of how the data is dirty. Now, how to clean the data? That is the data cleaning in the real way. What techniques, what algorithms we should use. That's what we want to learn. And that is the data cleaning. So, how we do that? Fill in missing values. Whatever values are missing, those we will fill. How? That we'll see. Smooth the noisy data. The data are noisy. So we have to smooth it. Right? How? We'll see. Identify or remove outliers. Data which are not following the normal behavior of the other data. Those will be removed. And resolve inconsistencies. These are the ways to do the data cleaning, right? Next is data integration. That means integration of multiple databases, data cubes, or files. You can say, why do we require such things? See, data mining is nothing like we are having few KB or few MB databases, and on that we are applying the algorithm. So, what do we consider? We have first only talked of that we are having petabytes or terabytes of data. So, are we considering the data of single database? No, it is not so, right? So, integration of multiple databases. Say for a company whose branches are available throughout the India, so that data will integrate. You can say one company is there, so you can say database format for all the branches will be same. Not necessarily, right? It depends on the requirement of that particular branch. It may happen, right? So what we have to do is we have to integrate the multiple databases, data cubes, or files, right? It is not always that we are having the data in the form of database only, right? So we need to consider that the data is structured or unstructured also, right? Next is data reduction. Reduction? Why should we reduce the data? See, as we know that data is in terabytes or petabytes, If we apply any simple algorithm, as I was talking to you yesterday, that I want to get the data of your class, that whether you like X movie or not. Now, there we consider only 60, 70 students. But, when we are having the data mining system, where we are having the data which is terabytes or petabytes of data. If we apply any algorithm on that, it will take too much time to give us result, isn't it? What we computer engineering people do, that is, we try to reduce the execution time. We are trying to reduce the space, memory, which is being used by the algorithm. This is what is the normal optimization we do to any computer algorithm. For data mining also, the same thing we want to have. So what we do, before applying the data mining algorithm, what we do is we try to reduce the data. You can say, ma'am, it is so simple. Just take half of the data, just take one fourth of the data, and it is fine. But, in your class, say 70 students are there. If I take the input from 10 students, will I be getting the same result or similar result if I ask to all 70 students? Are you agree with that? That both will be giving me same results or almost similar? Probably not. Probably not. And that is what is the condition for doing the data reduction. What we say is, for doing the data reduction, we should have reduced presentation in volume. Yes, we will be using the algorithm which will reduce the data set, which will reduce in numbers, which will reduce in number of rows, which will reduce in number of columns. But, but, produces the same or similar analytical results. What if I do the reduction, but I'm not getting the exactly same or similar analytical results? If I'm not going to get, then what is the meaning of reduction? What was my purpose? That is, whatever is the data, based on that, I should be getting the analytical results. But when we reduce it without considering the principle of the data reduction, if we apply, then we'll be getting the result which is of no use. And the principle of the data reduction says that we should obtain reduced presentation in volume, but it should produce the same or similar analytical results. Otherwise, we should not apply such data reduction technique. Are you getting that? So in that, what do we consider is, we are considering dimensionality reduction and numerosity reduction. Now the name itself says that dimensions. We used to say that dimensions, 1 dimension, 2 dimension, 3 dimension, and dimension, right? The number of columns, we can say, that is to be reduced, dimension. Fine. Second is numerosity reduction. So what is that? There we try to reduce the number. So what number? Number of columns? Number of rows? No. Here typically we are considering the data value. If I am having the data value in the form of, say, few lakhs, like say 10 lakh, then 10 crores, what I'll do is, I'll try to have the reduction in that number value. Instead of 10 lakh, I'll convert that to 1. You can say, how can you do that? You can change the unit, isn't it? You can divide it. So 10 lakh is there. So you can say that 5 zeros are there. So what I'll do is I'll divide whatever numbers are there in the database by 10 lakh. So I'll be getting the data in smaller range, right? Okay, so that is what is the numerosity reduction, where we are trying to reduce the number, okay, the value we can say. And for that, people are using, not for numerosity reduction, but we can say that for data reduction, people are using the data compression. This is what we are having a little bit idea, that if our file or our folder is so big and we want to get it on the pen drive, we used to compress it and then after we take it on the pen drive, right? Nowadays nobody is using pen drive also, isn't it? People are putting everything on the Google Drive and then after use it, or otherwise any other such external internet cloud based storage where we store our data and get it wherever we want to have, right? Okay, so next is data transformation and data discretization. Now what is that? See, transformation, that is, we want to convert data in other form, in layman's terms, right? In layman's terms, we say that whatever data is there, we want to transfer. We want to transform it to other format, right? We may consider that it is like you are having 10,000 and you are converting it to say 1, right? So you can say that you are doing the normalization, right? You are doing the normalization. You can say concept hierarchy generation. That also, if you are having the city concept as city and you are trying to represent it in the form of say country, we have seen that, right? City, then state, then country, right? Then continent. This hierarchy of the concept we already know. Fine. Okay, so what do we say is, if the lower level concepts are being replaced with higher level, or higher level concepts are being replaced with the lower level. Fine. So such thing we can do. Next is aggregation. Aggregation also we can be taking, that is techniques we are talking of, right? Aggregation, like we can say we can take the average, right? Or maximum or minimum or something like that. Fine. Okay, discretization. Discretization is where whatever continuous data is there, we are trying to make it discrete. Real data, we can say real numbers are there, we are trying to make them integer, right? This is the example of discretization. Fine. So forms of data pre-processing. Now see, we have already seen that we need to have data cleaning, data integration, data transformation, data reduction as the major task in the pre-processing, right? Okay, so as we already know, why should we make these figures? These figures represent the concept very pretty, very nicely. See the figure, and the figures are not so difficult. See, anytime if you do not know the exact figure of a particular concept, you can make it yourself. You know the meaning or the concepts which are there in that particular thing. Let's see that. Data cleaning, right? Here we show the image. No need to read the text. It is fine. You can say that here, say database, or you can say box, right? Box. So you can say database is there, and you can say that the stones or you can say dirty things are there around it, right? Dirty. We mean to say that data is dirty, right? And After cleaning, what we see is the box database, and which is clean. How do we say that? It is clean, and you can say it is shining with the light. You can say light is emitting out of this box database, right? We mean to say that it is being cleaned, right? See, always the graphical representation of anything makes the concept clear. It is but obvious. For any particular concept, you should know what figure you should make. If you have made the figure properly, if you are writing less about that concept, if you do not know much more, then too it is giving you good marks. See, if you want to get full marks, it is but obvious that you have to draw the figure also perfectly, and concept also you should write perfectly. But if you have forgotten what to write in the text, but still if you remember the figure properly, you can put it and you can get good marks. So, how the effective presentation? What people are doing is people are just writing and writing and writing, and say 10 pages people have written, then it is useless. But if you are writing, say, only one page and good figure, that's all. See, for making good figure, it is not required that you should have the capability of good drawing. No, it is not at all required. See, simple things all can draw, right? So try to cultivate that. So next is data integration. Now we can see that very easily. This is one box type data, this is one cube type data, and this is flat file like data, right? And now what we are doing is all three are combining, and we are able to see one database or one box, we can say. And that is what is data integration. Meaningful presentation of the concept is good figure, right? Okay, then data transformation. What data is available here? -2, 32, 100, 59, 48. Now what data we are having? Zero point 0.02. We can understand that we have divided the data by 100, right? Then 32 by 100, so 0.32. 100 by 100 is 1, right? So that is what is data transformation. Fine. Data reduction. Now see here, you are representing data reduction. Okay. Here what we are having, say data is given, say number of rows are there and number of columns are there. Number of rows T1 to 2000, and columns they are from A1 to A126. Fine. Now reduction we want to show, right? So don't make this rectangle and this rectangle of the same size. Okay, what should we do is we should have this smaller rectangle, then only it can say, it can show that it is reduced data, isn't it? So what we do here is, here we are having, say, T1, T4, say T1, 4, 5, 6. It is any number, right? Depends on the algorithm. This is just the figure to show the things that it is reduction, right? So what people are doing is mistake. What students are doing is, this figure they are making like this. They are having the smaller rectangle here and then writing the same text as it was there in the original text, original figure. So that makes the figure wrong, right? Here you should have the smaller rectangle as figure, as well as whatever number of rows you are showing, that also should be reduced, and whatever number of columns you are showing, that also should be reduced. So here it is A126, so here it is A115. Why 115? You can take any number, right? Here it is 2000, here it is 1456. So the data is being reduced, right? So that's what we can show with the figure, and very clearly we can depict the things with this beautiful and simple figures. It is nothing like it is too complex, and people with not good drawing cannot do. No, 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 we can do, right? People with good or bad drawing can also do the things, right? Now, data cleaning. How we do data cleaning. Data in the real world is dirty. Lots of potentiality, incorrect data, instrument faulty, human or computer error, and transmission error. Because of this, we can have the dirty data. So, what to do? We should handle that. How to handle that? That is, we should clean the data, right? So, how we are doing the cleaning? For that, we can say incomplete. That means lacking attribute values, lacking certain attributes of interest, or containing only aggregate data. For that, we can say occupation is equal to, say, double quotes empty. So, missing data, right? Noisy, then you can say it contains noise, errors, or outliers. That is, we can say the example is salary is equal to minus 10. Inconsistent, containing discrepancies in codes or names. As for example, age is equal to 42, so birthday cannot be there in 2010, isn't it? Older rating was 123, but now rating as A, B, C. So it is inconsistent. Discrepancy between duplicate records. Fine. International. No, no, no. Intentional. Right? Intentional. What do we say? That say January 1 as everyone's birthday. January 1 as everyone's birthday. Is it possible? Everybody is having the birthday as January 1 only. Not at all, isn't it? People may not have selected the data from the calendar, right? Whatever is given to fill the data of date, isn't it? So, or intentionally, I don't want to give it, right? And whatever was there by default, you will take, your system will take. So that will be wrong, right? And that needs to be replaced. But how? So, incomplete or missing data. Data is not always available. Many tuples have no recorded value for several attributes, such as customer income in sales data. People may not feel that, right? People may not feel the value for that. So, what should we do? Put compulsion on the customer? Give the data? No. Programmer can make the design in such a way that customer has to enter each and every detail. But if you have to keep it optional, in many cases, people have to make the design where they have to keep some fields optional, right? Depends on the particular business, it is required, right? Okay, so it may happen. So if it is optional, people may not fill the data about that, right? So what to do? You can say that, are you designing the application? What you are doing is you are having the data and you are doing the data mining. You want to do the data mining to get the analytical results. So, are we going to redesign the application and get the data again? Obviously not, right? Programmer, if have considered the field as compulsory in the application, we could have all the data available. But we are talking of current scenario. Just now, not in the past, we are going and changing the data. or we are not going to modify the application and getting the data again from the customer. No, we are not going to do that. We are having the data, and that is the historical data. On that we are working. So if the data is missing, we just have to deal with that. We may replace it by some values, or which values, what are the techniques that we need to see. Fine. Missing data may be due to equipment malfunction, inconsistent with other recorded data, and thus deleted. Data not entered due to misunderstanding, that also happens. Certain data may not be considered important at the time of entry. See, as I have given you the example that before few years, people were not using mobile, people were not using email address, but nowadays almost all are having mobile and all are having at least one email ID, right? But before few few years, was it there? No, it was not, right? Okay. Not register history or changes of the data, right? Missing data may need to be inferred. Missing data may need to be inferred. From some other data, we can infer the values for missing data, right? So, we want to know how to deal with the missing data or how to handle the missing data. For that, the techniques are, the first one says that fill in missing values. Fill. What to fill? Should I fill 10,000 as the salary where the data was missing? Can I? That person may be having the salary in lakhs of rupees, and I do not know. I have just put the 1,000 or 10,000. Is it correct? Do you have any technique by which you can say that what you have done is proper? No, you do not have, right? So random values will put? No, obviously not. So we'll see the techniques how to fill in the missing values. Fine. Identify outliers and smooth out the noisy data. Correct the inconsistent data. Say, we have talked of the data wherein, say, birthday is, say, in 2010, and we can say age is 42, which is not consistent. So what we can do? Very simple example and very simple solution we can give, that is, either you change 42 age to whatever is according to the birth date, or otherwise change the birth date, that is birth year, according to the age whatever is being filled, right? You can do that. Many a times you can say inconsistent data is somewhere like, in our India, according to our India, we say that people who are married, they are having the children, right? It may be having the data wherein you can say that two children's two children's are written, but two children are written, but the marital status of that person is unmarried. So in India, we can say that is not possible. Or you can say, no, ma'am, Susmita Sen is there, Karan Jauhar is there. They are having the kids. They have adopted those child, right? They have adopted the children. So you can say, now should we consider it as the inconsistent data? No. Now we cannot say it as inconsistent data. It is consistent, right? But, 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 before a few years, that was possibly not there. but now it is there, right? Single mother is also there and single father is also there, right? They adopt, they adopt the kids, right? It is possible, but these days, right? Still, there are the laws in our India that probably do not support single mother and single father if they do not have proper income or many other constraints are there. So we are not talking of the law, we are talking of data mining. Fine, okay. So how to handle missing data? Now, for that, first of all, ignore the tuple. Usually done when class label is missing when doing the classification and not effective. See, to ignore the tuple where the data is not there is not effective when the percentage of the missing values per attribute varies considerably. We can say that too much missing values are there, or you can say that too much variations are there for missing values. So for that particular field, I mean to say, so at that time, we cannot ignore it. One more thing is, let us say that I want to get the data of your class. 70 students are there. And what I'll do is, I'll take the data from 10 students. Actually, I'm not doing, I'm taking the data from all. But 60 students haven't entered the data for whether they like movie or not. So what happens? I am having the data only of 10 students. From that, I have to decide the analytical results that whether the movie is good or not. So, will it give me the proper result? If I ignore the people who haven't entered the data, I will not get the proper results, right? So, it depends on whether the missing data is in the count which can be ignored or not, as well as if the variations are more for, you can say, for different columns we are having the missing values, we cannot ignore that because it can be giving impact on our analytical results, right? So at that time, ignore the tuple is not the proper way to deal with the missing data, right? But that also is one way to handle or to deal with the missing data. Fine, okay. Second one is fill in missing value manually. It is tedious, infeasible. How can you say that? 70 students are there. I can fill it manually, no issue. But, 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 are we talking of only this small data? We are talking of the data that is terabytes or petabytes, right? So, can we fill the missing values manually? That is not at all possible, right? Okay, okay, go to next. But is it feasible in some cases? Yes, it may be. That is, say, after applying whatever automatic techniques are there, and when, say, small number of missing values are only available at that time, you may inspect yourself and you can fill it manually. Otherwise, it is tedious and infeasible task. Okay. So what are the automatic techniques to fill the data? So fill in automatically with a global constant. What is global constant? That is, as for example, where the data is not available, We'll replace that with unknown or a new class. What to do? Should we write it as NA, that is not available? So some value will be there, isn't it? The attribute mean. But can we apply mean for name like field? Like say, names are not written. Names are missed in few fields. So what to do? Say, we are having the database 1, database 2, database 3. There, the field was, say, in database 1, it was name 1. In other, it was name 2. In other, it was name 3. And where for this name field, we can say that data is not available. Can I replace that with attribute mean? Obviously not. Why? Because name is text. Can we take mean of it? No. If the field is numerical, then only we can have the attribute mean. And with that, we can replace such missing values. Fine? Okay. The attribute mean for all samples belonging to the same class. What do we say? Should we take the mean and replace? Yes, that is one way. But smarter way is take the mean of a particular class and then replace with that mean. What do we mean to say? Say, for example, in your class, few groups are there, right? Say, design engineering groups, right? So what I'll do is, if say, here, say, Mahavir and Om, they are there in the same group, right? Sumit, right? These three people are there in the same group. So what I'll do is, the data is missing for, say, Om. So what I am having, Mahavir and Sumit both have entered the data, right? They are there in the same group. So what I'll do is, I'll take the mean of the data of these two people who have entered the data. Take the mean of it. And then we'll replace the missing data for Om. Are you getting that? Okay. So instead of taking the mean of whole of your class where the data is available, what I'll do is, smarter way is, for a particular class. Class is your third year computer class, or you can say final year computer class, or you can say second year electrical class. Is it that way? See, it may be depends on your particular application, but we are not talking of that class. We are talking of the class, that is a label which is being used in the classification, right? So here you can say that your design engineering groups, they can be considered as one class. And from that, if for 1% the data is not available, fine. We can take the average of other 2% data, and that will be used to replace the missing value for the same class person. Fine. How to handle the missing data? That's what we were looking at. So one more way is the most probable value. Inference based, such as Bayesian formula or decision tree. Most probable value. Forefathers were having this way, this characteristic. So the children or grandchildren will be having similar characteristic. Based on that, we can replace the value, right? That is the layman's concept, but here we can use it using, say, Bayesian formula, or we can say decision tree. What are they? That we will see. And Bayesian formula is, I think, already known to you. If not, we'll see that when we'll study that particular topic. Fine? So, noisy data. Noise. What does that mean? Random error or variance in a measured variable. Incorrect attribute values may be due to faulty data correction, no, faulty data collection instruments, data entry problems, data transmission problems, technology limitation, inconsistency in naming convention. Inconsistency. Hmm, what do we mean by that? You consider my name as Ami Choksi. I have considered my data as Ami Tusharkant Choksi. Person is same, but the name written is different, right? Naming consistency problem, right? Simple example. Other data problems which require data cleaning, they are duplicate records, incomplete data, or inconsistent data, right?